L'Hopital's rule. We're going back to limits. Yay! Um, okay, so remember limits. Sometimes when we did direct substitution, we ended up with something kind of indeterminate, 0 over 0, infinity over infinity, something like that. And we had some ways to take care of that. We would factor. We would cancel out the factors. We would rationalize the denominator. Like, let's look at this one. If I plug in 3, I get 2 times 3 squared minus 3 minus 15. 3 squared minus 3 minus 6. I end up with 0 over 0. Not good. So the better thing to do was to factor it. And that would end up being 2x and x. I need a 5 and a 3. So it had to be 5 and a 3. Negative 6 plus 5. In the denominator, I'd have x and x, negative 3, and a positive 2. So notice these canceled out. That meant I had a hole in the graph. But it also allowed me to figure out where the graph was going to at that hole. When I plug in 3, I get 2 times 3 plus 5 over 3 plus 2. So I get 11 over 5. Now, L'Hopital's rule makes it even easier. L'Hopital's rule says if the limit of f of x is 0 and the limit or it equals positive or negative infinity. And the limit of the derivative of f over the derivative of g equals some number. Then the limit as x approaches c of f of x over g of x also equals that number. Oh, I know that's confusing. Let me just show it to you. So if we plugged in 3, we got 0 over 0. L'Hopital's rule says, once I've shown that, then I can take the derivative of the numerator and take the derivative of the denominator and now plug in 3. It's like magic. Let's see if it works on a lot of stuff that we'd already done. Remember, the limit of sine x over x as x approaches 0 was 1. Well, let's prove it using L'Hopital. What's the derivative of sine x? What's the derivative of x? What happens if I plug in 0 for x? I get cosine of 0, which is 1. 1 minus cosine x over x. That went to 0. Let's prove it using L'Hopital's rule. The derivative of the numerator is going to be, that's 0. Negative cosine, the derivative of that would be sine. As x goes to 0, I'd get sine of 0, which is 0.